Cool, then I will start. Yeah, thanks. Welcome everyone, also on behalf of Sophia, to this session, which is entitled Data Modeling and Processing for Historical Scholarship, How Research Design and Methodology Affect Data Management. Arguably, it's less a punchy title than one would have wanted. I had to think about titles of early modern books, which were maybe slightly boring, but they did do quite a good job in conveying sort of the content of the books themselves. And so this also holds true for our session, because what we want to do here is basically to explain the links between, on the one hand, the humanistic component of research project, and on the other hand, the digital components. What this means is that we will talk about how the research questions affect the data that we're working with, how we structure the data, how we transform the data, and how that is also in turn influenced by the requirements of the data formats and the tools that we were using. Now, we thought about, because this seminar series, as you well know, is quite ambitious in that it tries to do hands-on sessions within a period of 1.5 hours. It's ambitious because we're all working with different operating systems. Often software has to be installed, and we felt like we could do a hands-on session on, say, a particular transformation scenario. But if this is sort of disconnected from the wider research context in which such a transformation scenario takes place, it's not really that useful. Also because we don't know about the interest and the skills of the audience. So we felt to use a slightly more traditional format. We present, first Sophia, then we present our projects. We do this in such a way that we structured the presentation in similar ways, and we address similar topics so as to foster comparison between the two projects. Then come at a small conclusion where we try to tease out sort of the general strengths of this presentation, and then we hand over to you really. The last part of this workshop is a Q&A and hopefully also group discussion. I mean, we hope at least that some of the themes that we address are of interest, and we expect that there are members in the audience who have dealt with similar questions, but how to shape a research project, how to integrate a digital data component in it, and would like to also talk about their own lessons learned and experiences. But that's the final part, as I said, of this workshop. I will now hand over to Sophia, who will start presenting her project. So, Sophia, take it away.
Thank you so much, Jaap, for the introduction. As you said, we are going to present two projects, and I will present one about art history and specifically iconography and iconology, and semantic web applications. I will give some technical details to give the perception of the insights of the work that there is behind in order to make this kind of project, but I would like to stress that the focus is on the methodological part. So if somebody is not familiar with semantic web technologies, please don't worry about it. Don't worry about I'm citing things that are new for you, and please don't focus on trying to understand what is the specific data format or technology, because that's not exactly the focus. I just wanted to include some technical things to give more idea on the background information. So the project is called Diving into Artwork Interpretation Through the Lenses of Semantic Data, and focuses on a specific art historian, which is Erwin Panofsky, and it was a part of my PhD project. Iconography and iconology are two words referring to a branch of studies of art history, focusing on the study, understanding, and interpretation of the subject matter of artworks. And whereas iconography focuses more on the recognition of the subject itself, for example, in this case, the theme of the discovery of honey, in this artwork by Piero di Cosimo. Iconology concerns the understanding of such iconographic subjects as documents of social cultural phenomena, or of more insights on the particular perception, values, and worldview of the artist making the artwork. So it's a quite complex domain, and I want briefly show you the complexities through this example. Saying to you what Erwin Panofsky says, interpreting this artwork. And as I said, it's the theme of the discovery of honey. So it's a story that we find in Ovid's Fasti. So we have a textual source as a reference for interpreting the artwork. And why we know that is Ovid, because what is depicted is some satyrs that are making noise in order to gather the bees and trap them in a hollow tree, which is a practice, an ancient practice to let the bees gather in order then to so that they create the honey and in order to be able to gather the honey. But it's not so obvious what is the link with Bacchus, who's present here, and is Ovid the source telling us that Bacchus was entitled as the one who discovered honey. And if we go further into the interpretation, we can take the social value of Bacchus as the god of wine. So he is associated with a civilizing aspect. And this is very important in Panofsky interpretation because by comparing this artwork with other ones that were, according to Vasari, commissioned all together at the same time, we can perceive the personal interpretation of Piero di Cosimo of the theme, as he's always underlying how civilization brought some peaceful atmosphere, peaceful traits to the scene of nature that is just dominated by beasts. And this is referred to also the landscape that we see in the background, because we see that is a paysage moralisé. So the landscape is a symbolic one. There is a peaceful atmosphere and nice weather on the left part, where there is some form of civilization, whereas on the other side there are cloudy and kind of inhospitable landscape. So you can see just from the analysis of one painting how much complexity is included, and we don't consider only the relations between the characters depicted, what they are doing, the tool they are using, but also we refer to external textual sources, other artworks, and references to other artworks by the same artist. So the main research questions for this domain is can domain-specific questions be answered in a quantitative way? So what would be the advantages of creating and analyzing data about iconographical and iconological interpretations? So my research question is more methodological, I say. So I wanted to explore if we have data, if we can create data about this topic, would this be helpful for the discipline itself? Would be enriching the knowledge that we have with different kind of analysis. And in order to do that, one of the first part of the approach was the analysis of the domain itself, composed by a study of the domain. With domain, I refer to the discipline, so the area of knowledge to which I'm applying this kind of study. So in this case, it's iconology and iconography. And To detect the interest of the domain, I did a study of some iconographical and iconological studies, and I tried to extract the questions that they were implicitly answering. So, for example, how does a representation of an iconographical subject vary? This is a very core question of iconographical studies because the focus is not just recognizing the subject depicted, but also try to understand how it varies over time, which are its attributes, how it's depicted, but also does it acquire different meanings in different contexts. Another one questions is which sources and visual aspects motivate recognition in the artwork of cultural phenomena. So how do we see, how do we perceive deeper meanings that may be embedded into the artwork, and which are the contextual sources, which are the other artworks that are linked to the artworks I'm examining to understand in a deeper way what I see. And another one example is how do visual shapes migrate and reappear across cultures. And there is, for example, a study by Discover who tries to trace the evolution of symbols of the eagle and the serpent in a worldwide landscape and from Babylon onwards. So this question is also representative of this kind of studies. I present here just 3, but I collected 12, and I tried afterwards to express them in a real query over data. So the first problem I faced is there are no data available, and that's because the description of artwork subject is usually made available in a free text format in catalog entries. So structured data, and with structured data, I mean data that can be, for example, described with a table. So not free text, not just a text, but data that are processable by a machine. And also the control vocabularies that are mainly used in the domain, such as icon class and getty, which are really valuable resources. But as they are vocabularies, so they identify a specific iconography with a specific ID, they don't express all the complexity of relations that may occur in the different iconographies, in the different analysis of a painting. And so that's why I created manually my data, and that's why also I had to narrow down the research to a case study, because of course creating manually data is time consuming. And I decided to focus on 3 books and 1 article by Erwin Panofsky, which are his main books. And I focus on him because he has he is one of the art historians trying to define in the most detailed way and extensive way the domain, and is one of the first trying to do this. And I extract only the information that are relevant to the aim of the study, so the iconographical and iconological interpretation. So the approach was reading the text and expressing them in a table according to a modeling that now we see. For the data modeling, I choose to select semantic web technologies. Semantic web is a web of data, and his structure is basically a graph with nodes and relations. And inside the semantic web tools, ontologies are one of the fundamental ones. Ontology is a formal description of knowledge expressed as a set of concepts and relations among these concepts within a domain. And so for this reason, they offer the opportunity to express semantically complex information in a formal way. But how to do this for a specific domain of knowledge? So during the ontological modeling, the approach that I adopted is a top-down approach. So I stick into the discipline itself, all the theoretical theories that were available, and of art historians trying to express how their approach was working. And I finally focused on Panofsky Interpretation Act, because he's one of the first trying to do it, to describe it extensively and quite in a consistent way in his explanation. But of course, I took into account also the hints that are provided by other art historians. And I define competency questions, so some questions that are related to the one we've seen before, but which were trying to address such questions according to the theory of the art historian. And all the development was tested over real examples, real case study, not only by Panofsky, but also by other art historians. And his interpretation act is the basic feature is that he divides the interpretation act into 3 levels of understanding, going from a more superficial one to a deeper one. And in the first level of understanding, things, for example, as object, actions, natural elements are recognized. And if the observer is knows the standards for representing iconographies used by the artists used at the time, it can recognize also the symbols, the stories, the attributes, and the characters and their meanings. And as we've seen here, it would be the discovery of honey. And all the related meanings, paysage, moralité, and so on. And finally, if the interpreter is expert of the culture of the time, it can even go deeper into the interpretation, as we've seen Panofsky in this case tries to see the personal beliefs of the artist and personal interpretation of the artist through the way things are represented through symbols. Just to give you a brief idea, this is a part of the ontological modeling. As you can see, it reflects the 3 levels of interpretation. So there is a class called recognition that is superclass of recognitions in each level of interpretation. Each recognition identifies one subject, and some more information about this recognition can be provided, such as the agent doing the interpretation, and also what is cited as evidence, as support of such recognition. And the final interpretation is a collection of all this recognition. The final interpretation is represented by the class interpretation description. I will not delve into the detail, but I just wanted to show you how an ontology modeling may look like. And as tools, I use Protégé. And the ontology was published with a permanent URL so that it's guaranteed that it's available over time. And according to this model I presented you, and reusing other available ontologies, other available standards, it was possible to structure a Google spreadsheet. So I organized a Google spreadsheet so that I could easily then access it and convert it into RDF data, so in semantic web data. And here I just wanted to show you how these tables were organized. So there are several tables for focusing on a specific topic. And in the first part, you see the table for artworks metadata. every artwork has an ID, which is recalled in the other tables to connect the interpretations of each level to the artwork. And you see, for example, that a man is identified and a man has ID 1. And this man is recalled in the second level interpretation. And the man in this way is connected to the subject Hercules, for example, and so on. This is the basic structure in which it was possible to establish relations between subjects recognized at different levels with the artwork. And to be consistent in the description, I used a control list and verify the terms in another one table. So that these are very basic principles for the data collection. And then, as I said, the structure of the table is very related to the ontological modeling that I used. And I used a Python script to access the spreadsheet table and convert such information into a final RDF data. And here, for example, you see in the Python script line that this term line material is accessing the cell of Ivory and saying that if this cell is not empty, then it will convert it into the final RDF data. So in this case, the subject, the ID of the artwork is linked through a relation reusing the CDOC theorem ontology, which is the standard for the museums domain, and expressing the material of something. And then this Ivory is the object of our triple. The triple is the basic structure of RDF data in which you have one node as a subject, one property as the relation. So CRM P45 is our relation here. And it has another one node as the object that you can see in the final RDF data. So that's the backend work of converting the data. And finally, I want to show you how the domain-specific questions were performed. So every query, every questions of the domain that I had, I tried to express it in as a query. So in a SparkQL query, SparkQL is the language used for querying RDF data. And for example, going back to our initial question, what are the sources motivating the recognition in the artwork of cultural phenomena? Here I did a query asking to retrieve the evidence cited by recognitions identifying a cultural phenomenon, and also their type, and through some data manipulation with the pandas Python library, I grouped them to see their frequency. So you see how having this data with a very detailed and complex structure is possible to address these questions that are interesting for the art historical inquiries as SparkQL queries. And here I provided just a little visualization just to give an example, but there are, of course, many more, and with different type of visualization to access all the information that is stored in different ways and according to different questions. And I presented the data and the analysis and visualizations, and also the query made on a website. It's a dashboard that is interactive, so there are different ways to access the data, and the data are exposed through a SparkQL endpoint and also through a permanent URL. And I'm stressing this because it's important also when you create a project to think about how to make the information accessible and in a permanent way according to the FAIR principles. So this was my very brief insight on the project. And to conclude, I want to stress which were the theoretical and practical issues. So first of all, as I said, there were no data available. So I had to limit the research to a case study of one art historian. And there were challenges in defining unique theoretical model on which to base the ontology, because there are multiple theoretical approaches available. And also the discipline, the concept itself is very various and different. And another one practical issue, I would say it was the learning the skills to work with semantic data. So all Python ontologies, how to collect data, and all the semantic web standards needed to work with this kind of data. So this was my insight, and we can discuss better later. And also for the questions, we can see them later. And now I will pass the floor to Jaap for presenting his project.
Right, my project doesn't really have a title yet. There's a title mentioned on the website of the Institute of the IEG, but it's really a placeholder, as I hinted at the beginning. Coming up with catchy titles is not really one of my strengths. And I will tell you just a bit about the historical context, as well as the historiographical context, just so that you can make sense of what I'm doing. So this project focuses on a schism in the Catholic Church in the Dutch Republic. The Dutch Republic was the predecessor of what's currently the Netherlands, was officially a Reformed Protestant country. And because of that, Rome considered the Dutch Republic to be mission territory. And there was a Catholic mission was launched at the end of the 16th century, the Missio Hollandica or Holland Mission. And this mission was led by an apostolic vicar. In the late 17th, early 18th centuries, this was Petrus Codde, but he was suspended in 1702. And from that moment onwards, you see that the Dutch Catholic community is starting to fragment. On the one hand, you have lay people and priests who remained loyal to Codde and who sided with him. And on the other hand, you have lay people and clergymen who sided with Rome. So de facto, a schism started to emerge, and this schism was institutionalized in 1723 with the election and later consecration of Cornelis Steenhoven. You see a portrait of him in the right-hand corner in less happy times. This portrait was made just after he had passed away in 1725. But from the moment of his election onwards, you could really talk about the existence of two competing Catholic churches in the Dutch Republic. On the one hand, the Roman Catholic Church. On the other hand, de Rooms-Katholieke Kerk, der Oud-Bisschoppelijke Cleresie. Nothing wrong with the name, apart from the fact that it's slightly unwieldy. And nowadays, it's known as the Old Catholic Church. And in the context of this presentation, I will talk about the Roman Catholic Church on the one hand and the Old Catholic Church on the other, just to make it a bit easier. Now, the historiography has spent quite a lot of time discussing the Schism of Utrecht, but mainly from the perspective of church history. That means a focus on the church as an institution, a focus on the clergymen and their theology, and the laity has been largely overlooked. So my project aims to remedy that historiographical gap by focus on lay experience in behavior and behavior in the context of the Schism of Utrecht. It does so by studying quite a long period from around 1680, when the default lines in the Holland mission became more and more apparent, to around 1775. And it addresses themes like confession coexistence, the practice of religious toleration, also lay agency. How did the decisions made by the laity shape the Schism of Utrecht as it evolved locally? And also the topic of religious choice, and that's what I will focus on in today's presentation. So the idea I had, and I have to be honest, I'm less a pioneer than I would like to be, is to look at these lists of baptisms and marriages in order to understand the movements of Catholic lay people between these competing Catholic churches. As I said, less a pioneer than I would like to be, because this has been done before. 4 articles have appeared which use exactly the same sources to understand religious choice in this context, but they made use of a completely different methodology than I did. The information you can find in, for instance, this list of baptisms is what we can see here. I've transcribed one entry that on the 8th of September on 1756, Henricus, legitimate son of Jacobus van Haaften and Maria Voet, was baptized, and the godparents were Clemens van Haaften and Cornelia van Haaften, who, it was also mentioned, was the widow of Henricus Sipkes. Luckily for me, this data has been transcribed and made available in digital form by various Dutch archives, assisted by an army of volunteers. So what these archives did, and these volunteers did, is to transcribe the data in these lists of baptisms and marriages in XML. Luckily for me, the archives made use of the same XML schema, although subtle differences in applications exist. And this XML data, this structured data, which can be searched, as Sophie already explained, is available via online databases created by these archives themselves. But there also exist larger databases which sort of aggregate all the data created by the archives so that you have one point of access. Having this is already phenomenal, because just from around the world you can just access these online databases and do your research. But for my purposes, just having these databases wasn't enough. I needed to get at the raw data and needed to export and transform it, because I already knew that I wanted to add more layers to the data. I just didn't only want to have the names of the people who participated in particular events, baptisms and marriages. I also wanted to add data, for instance, about their socioeconomic profession and so forth, socioeconomic status and profession. So in order to do so, and in this I needed to get the most relevant data out of these large XML files. And a good friend and a former colleague, Dr. Demival Vasquez, was so kind to write a Python script which allowed him to export the most relevant data and save it into large CSV comma-separated files. So a data export, this is a close-up of one of the data exports that he gave me, looks like this. So you have basically various rows which details the people who participated in a similar event, in this case, a baptism. So these large export files focused were some sort of the starting point of my research. My project focuses on 3 case studies, 3 mission stations, which are basically parishes in a missionary context. So I need to filter the data, and then I could start with data standardization. So this was necessary to, for instance, attribute unique identifiers to the people mentioned in the data created by the archives, and also unique identifiers to the events mentioned. For what the archives did do, every time they transcribed the name of a person, a unique identifier was added, but they didn't determine if person A was the same as person B, because of course it could happen that people appeared on this list more often. For for instance, because there's several children baptized. And it was for me on the basis of fairly time-consuming and also rather tedious genealogical research, I needed to figure out these family relationships. Was person A exactly the same as person B, or were there just two different persons who happened to share the same name? I then also needed to standardize the data, so settle on, a spelling variant of a name which I used as a standard variant. And then I also needed to add more data, like I said, about, for instance, the date of someone passed away, someone's profession, and so forth. And in the end, what I just created was basically a staging database. The staging is perhaps a bit of a misnomer, but it suggests that it's here for one part of the process, namely sort of an in-between stage between, on the one hand, the data created by the archive, and on the other hand, the data that I'm using in my graph database, more about which in a second. Now, the staging database has a tabular structure. It basically functions as a relational database. So if you start at the top, you have the overview of baptisms. There you have a person ID, which links to the people table, where I gather all information about the individual people in my data set. The ID of the baptism in this case refers to the event's baptism table, where I gather the information about the baptisms, and also specify in which church a baptism took place, which then links to the venues table, where I gather more information about these churches. So via a system of primary and secondary keys, like is usual in a relational database, I linked different tables, different spreadsheets in this staging database together. When this work was done, and for each case study, this was months and months of work. It was time to import all the data into a graph database. I use Neo4j, which is an open source graph database management system. You can import data saved in CSVs by means of import scripts in Cypher. Cypher is the query language used by Neo4j. You can import it into a graph database. Now, here you have some data in the graph database, and as I looked in the spreadsheet, a graph database has a similar structure to the semantic web, but what Sophia already mentioned, in that it comprises nodes related to each other, linked to each other by edges. So here you have, for instance, example of a baptism. You have the four blue nodes represent people that all participated in baptism, and the baptism took place in a particular church. Now, the nice thing is that already the data created by the Dutch archives stipulated or made clear what someone's role was at the baptism. So someone could be the person baptized, a mother, father, a godparent, and so forth. And this was really, information is really key in order to answer some of the research questions I have. Because having information about who participated in which event and which church that event took place makes it possible to say, okay, we see people first participating in the event in the Roman Catholic Church, later in the Old Catholic Church, and so forth. So we can say, okay, when did lay Catholics start to switch churches? Did lay Catholics participate in rites taking place in a competing Catholic Church? So do we, for instance, see people who were godparents at baptisms taking place in both churches? Did lay Catholics marry across the religious divide, and so forth? These are all kinds of questions which I can answer because of the way in which my data is structured. And this is what is, for instance, I zoomed in on one example in the graph database. This is Nicolas Zutveen. He was baptized in 1708 in a mission station that was part of the Old Catholic Church. Then in 1735, he married Vipian Lagretz, and all of their children were baptized in a Roman Catholic mission station, also in the city of Utrecht. So these are sort of the kinds of patterns I hope to detect. This is then a visual outcome of a query. You can also structure these outcomes in a tabular way. But these are the kinds of questions you can subject the data to. Now, already at the very start of the project, I knew that I was also interested in asking some other questions and to apply network analyses to this kind of data in order to try to whether it could help me to uncover some other dimensions of religious choice within the context of the Schism of Utrecht. So one important question is, did lay Catholics move to another church individually or not? Did they move, for instance, as part of larger collectives, of families, of lineages? Or was it not the case? Were families divided by faith and so forth? In order to answer these questions, a different type of networks needed to be created. So yet again, the data I created needed to be transformed. Here again, back to the graph database, where you have networks comprising 3 types of nodes. They are tripartite networks, as it's called, because on the one hand you have people, the light blue nodes, you have events, baptisms, marriages, here at the yellow nodes, and you have the venues in which events took place, the orange node here. If you want to ask questions about, okay, did people move collectively, you are interested in the relationships between people and not so much in the edges or the ties between, you know, people and events. So in order to create different sorts of networks, I use this term really advisedly because I was involved in sort of the conceptual discussions, but again, this is the work done by Dr. Demival Vasquez, whom I mentioned before. What we needed to do is basically to reduce the dimensionality of the data. We needed to flatten it. We did that by basically transferring some information from one node to other nodes in the network. So first, the events, a baptism, got a confessional attribute based on the church in which that baptism took place. So if it took place in the Roman Catholic Church or the Old Catholic Church. Then that confessional attribute would be transferred to people. So if people only participated in events taking place in the Old Catholic Church, the confessional parameter would be set to Old Catholic, vice versa for people who did do so only in the Roman Catholic Church. But then also you have people who participated in events taking place in both churches. They would have a confessional attribute which would be set to both, so that we could single these people out. And in the end, this led to projected networks. You can see it on the right here, comprising the links between people. If people participated in the same event, a link would be constructed between them. And where you can see that in this example, there are a couple of people who only participated in events in the Roman Catholic Church, the red nodes, only in the church of the Old Catholic Church, the blue nodes, and in the middle, a person who participated in events in both churches. And by creating these projected networks consisting of the people and the links between them, you get something like this. This is created in Gephi, which again is open source software, which allows for network visualization and analysis. And what I then was able to do is say, okay, you have several algorithms in Gephi which allow you to detect sub-communities within a particular network and say, okay, did all these people who participated in events taking place in both Catholic churches, did they form part of the same sub-community? Were they related to each other or not? It turned out not to be the case, but you know, that's another story. But this again is because of the data transformation and because of using certain software, these were the kinds of questions I now not only could ask, but also answer. To wrap up the introduction of my project, first, with regards to data, I had to deal with, some of the editorial decisions made by the Dutch archives that made the data available. Like I said, luckily for me, they made use of the same XML schema, so they structured the data in the same way, despite some differences in the way in which they applied the schema. But this was easy enough to deal with. Some editorial decisions had more impact because some archives decided not to capture all the information in these lists of baptisms and marriages. So I had to do some manual data entry myself. The availability of the data when I started this project in the summer of 2019, work to create this data was still ongoing. So that did influence the 3 case studies I chose because simply not all the data was available then. The quality of the data, I mean, most of the data has been created by volunteers with different levels of paleographical skills. So sometimes there are mistakes, but this didn't have a major impact on sort of the work that I was doing. Version control, that really pertains to the data that I was creating, because at some point I had data in the Excel staging database, in the graph database, and then also data created in the networks created by Demi. So I needed to stay on top of this. So what I did is that it was sometimes really tempting if I encountered an error or wanted to add data to do it directly into the database. But what I did do is constantly go back to the Excel staging database, change the data there, and then import it all again in the graph database, just to make sure that at all times I was working with the same version of the data. The software, of course, it's something you have to take into account, specific data formats and the requirements. It was especially when I had the data in the Excel staging database, I needed to see, okay, what data do I want to express as a node in the graph database? What becomes an edge? How do I create these constructions between the various nodes and so forth? And in my case, something which Sophia highlighted as well is, the skills necessary to do this kind of project. I mean, Sophia is really impressive that she acquired most of the skills herself. I was just simply not able to do so. So for me, the collaboration with Dr. Demival Vasquez was absolutely key. I did do a number of things myself, but some things, especially pertaining to network analysis and the creation of these projected networks, I just, don't have the skills myself and neither have the time to acquire them. So then you'd see, at least in my case, that interdisciplinary cooperation was absolutely vital and necessary. Right. So before heading over to the sort of more interactive part of today's session, just some final conclusions. As it already said, I mean, there's a constant sort of feedback loop between the domain or the discipline in which we work and the data that we use. And you could even further complicate this visualization by saying, okay, research project exists in a certain discipline. There's a feedback loop between them. But there's also a feedback loop between, on the one hand, the data, how you structure the data, and also the requirements of the software and the tools that you're using. And this is something I think, especially when you start thinking and designing a project, it's something to take into account. I mean, when we talk to funding agencies or submit grant proposals, we often, sort of piously convey the message that we know what we're doing, that, the project maybe is not a walk in the park, but getting from A to B is fairly straightforward. But as most of us know, especially with projects in the humanities, they evolve over time. You do go into different paths of investigation, of inquiry, especially if your project is source driven. And I think, you know, that is a really good and healthy thing. But what you do want to avoid is that, you know, at some point you go left with your project and you start creating a very, you know, detailed, granular data set, and then think, hey, the transformation of the data which is necessary in order to ingest it into a particular tool or database is getting more and more complex. Ideally, you at least have a vague idea and anticipate at the start of a project where it might be heading and how, you know, what's the structure of the data that you need at some point during the project. You can't envisage or anticipate everything, but thinking about this is really helpful. And then, you know, another thing, I think both of our presentations have shown that this kind of work is really labor intensive, especially if you have to create a data set from scratch like Sophia did. But even in my case where, you know, the data already existed in digital form, it still required a lot of manual labor in order to get it into the shape that I could start analyzing it and answering the research questions that I had. And then lastly, and this is also where we hope to be able to benefit from the collective wisdom of today's audience, is different projects have different needs. There's not a one-size-fits-all solution. So, you know, we are really also interested in your experiences in how you went about designing your research project and integrating the data into a research project.